Hi everyone, do you remember when we were able to create our own object? I believe we called it the Model T, and we were actually able to reference the methods that we created. I believe one of them was called start or drive. The other one was called sell or something like that. Well, guess what? Because strings are a built-in object, it already has wonderful built-in methods that are pre-baked into the Python engine. So let's take a look at the more popular ones. So we're going to get this party started both literally and figuratively, because we have a string that's literally let's get this party started. And that will be the reference to the letter T. So we'll just prove it. I'll just type in T and it actually shows let's get this party started. Incidentally, we are in idle, so we don't need to expressly say print T. But if we were actually editing a .py program, we'd actually have to explicitly say print T, and it pretty much gives us the same thing. That being said, let's see what string methods we have available to us. Now, to access the string methods, we can only do this in idle, just so you know. We can say T dot and press the tab button twice, and these are the methods that we have available to us. For example, we have upper and lower right here. So there's upper and we have lower right here. So what do they do? Let's go ahead and say T upper, and we will have to, in this case, utilize the open and close parentheses, because that essentially is a built-in function or method within the string object. So we're going to say open and close parentheses and press enter, and we can see that it produces the output, of which it takes every letter within the original string and uses the upper or caps version of it. Similarly, if we said T lower, which is yet another method right here, and let me press delete and then put in lower, it gives us the lower caps or the lower version of let's get this party started. Now, why would you do that? Well, for one reason, if you were creating an app that takes in user input into some sort of a form, let's say you were creating an app for somebody to sign up for a bowling league or something, you would want to make sure that there is an internal standard for all names. And you know, when people fill out even their name, they're going to use, perhaps one person will say this, like Jason Myers, like this. So for example, you have name is equal to Jason Myers, where there will be a space and there'll be the caps beginning for each part of the name. And some people might say, well, I'm just going to do lower caps throughout the whole thing. Whatever it is, you want to make sure that when it goes, whatever data is placed into your records, recording your storage, you want to have control of the formatting. So a popular method is making sure that all the characters within the name is in lowercase, for example. Let's talk about other string methods. We have B is equal to the string value of B. C is equivalent to the string value, not the integer value, but the string value of 3. We know that because it's in quotes, even though it is a number. So we can do type, and then B is string, and then type. C is also a string. So let's go ahead and see what methods are available. Once again, we use the dot operator, and we'll try this one right here, is digit. So this tests whether or not whatever B represents or is referencing is whether or not it's a number, essentially, whether or not it's a digit value. So we'll say is digit, and we'll open and close parentheses per the notation, because it is a built-in method or function, and it is false. Now, wait a second. If C, we'll do the same thing with C. So what we know about C, it is a string value. It is a string, so it's not seen as the object is not seen as an object type of integer. So it should also, now it shouldn't say false, it should say true, right? So let's go ahead and take a look, and it says true. So guess what? Even though 3 is enclosed in quotes, and it does recognize that it is a type string, the isDigit method is able to look inside that string and look and see what type of data is indeed inside. And even though it's inside of a string and the type of object is seen as a string, it's in terms of that particular method, it's able to detect that it is in fact a digit. So what purpose is this method? Well, again, if you were inspecting user input, you would want to know whether or not each of the characters was actually a letter, an alphanumerical letter, because you don't want somebody in the name field, which is an open field. They can technically put anything they want. Now, there are some illegal names out there. For example, you cannot name your baby King or Jesus Christ, but beyond that, somebody might try to sneak in some Perl code or something because the server might be using Perl, or even if the server is using Python, you might sneak some Python code in there and try to put in some sort of a worm or some sort of a DOS attack. So you can actually ensure that the proper data is being used. So if the field that you're asking for is name, guess what? The user is only putting in name. Does anybody remember Lindos? Lindos was when Linux was trying to compete with the graphical user interface of Windows. So they were trying to prove that Linux was as user-friendly as Windows. Now, this is like maybe 20 years ago. So they literally came out with a Linux distribution called Lindos, and the layout was similar to Windows. And actually, there are a couple of Linux distributions that do that now. And heck, even in Kali, there is a widget you can use to make your Kali desktop look exactly like Windows to prevent prying eyes from understanding and knowing that you're using the Kali desktop, the Kali distribution, because they might think that you're trying to exploit somebody just by the very fact you're using Kali. But anyways, so let's say, for example, we wanted to turn Windows 95 into Lindos. And how do we do that? Well, all we have to really do is replace the W with L. You wind up with Lindos 95. So one way that some data structures allow you to do is they allow you to say, to refer to the variable that has a reference to Windows 95, the string, and you can take the very first index, which is 0, and you can make that into, for example, L, and that would actually become Lindos 95. But strings will not allow you to do that. As it says, string object does not support item assignment. Now, there are other data structures, of which we will talk about in another video, that do support what they call item assignment. Strings are not one of those, because strings are a object type that is immutable. And I can't highlight that word enough. Immutability means that the string cannot be changed. So let's use another string method. Let's go ahead and do the dot operator and press tab twice, which again only works in idle. And there is a way to do this if you are in the .py text editor, but we're not going to worry about that right now. But we can see there is a method that will allow us to shift the W to the L, and that is replace. Now, the difference between the syntax of replace and is alpha or even upper or lower is that you can see the upper has an starting parentheses and an ending parentheses. Replace does not. So that means that we have to put something in replace inside of it. It actually takes parameters in order for us to actually execute the method. So for replace, case, we actually start, there are two parameters. We put in the parameter which we are going to replace, and that is going to be, in this case, W. So what it does, it will select the very first character that matches W, at least that matches the character we put in here. So the very first instance of a matching character W takes place in the 0 point. Then we put in the character that we want to replace it with. In this case, it's L. Now you notice that I used both single quote and double quote just to demonstrate to you that in this particular case they are interchangeable. I will close the parenthesis and we can see that it now equals Windows 95. Interestingly enough, if we printed X again, we can see magically that it hasn't changed because Windows, sorry about that, Freudian slip. Strings are immutable. So in other words, they cannot change. Now, some data structures are mutable, in which they can be changed, and we'll go over that data structure in probably the next video. However, for this video, we will just maintain the fact that you cannot change or update the existing string once you create it. But wait a second, is there a workaround? The answer is yes. So for example, in this particular case, you can say new string equals X dot replace W L, and let me close the parentheses. And oh, you know what? I just did a small little error because I used capital X. So let me try this again. And let me replace it with the lowercase x. I just pressed the caps button there, my mistake. And we can go ahead and print new string, and we get Windows 95. Now, we can also support not necessarily supporting item assignment, but we can also do the workaround. Let's say we have F equals foo, B equals bar, and we can say F is equal, now again, F is equal to foo, but we can say F equals F plus B, and F is now foo bar. So that's like a workaround. So another way we can shorthand this, there is a shorthand version of this, that is S is plus equal to B, and it's the same thing, and it actually doubled it, okay? And we can also say F is plus equal to another string, really bad, like this, and now we can say F is equal to foo bar, really bad.